So students, here is another question, and this is again a very important question with a standard result sometimes being used in couple of competitive exams. The question is: a boy is standing midway between a wall of a height h and a plane mirror. So this is a plane mirror. This is the wall of height h. So let me write it like this: height h and a plane mirror. Now, find the minimum length of the mirror. This is the mirror. We want to find the minimum length of mirror which is required for the boy to see full image of the wall. So he is, this guy, the image, if we see it here, the image, if the distance between the wall and the wall and the mirror, and in between the boy is standing, this distance is d. This is whole 2d, so this will also be 2d. The image of this wall in this mirror. Now we have to find the minimum length of the mirror which is required for the boy to see full image of the wall. Now we will approach this question in the way we have done the earlier question. How we have done the earlier question? We have drawn two triangles. We have taken up the triangles. We have proved that those are symmetrical, and then we have found out the ratios. So let's get started. Now, first thing is, again, same thing. What are the two extreme points of the image required? So extreme points are what? A and B of the wall, and we need to accommodate the entire wall. So first, what we will do is we will first take one, not the original thing, but we will take the image of that wall in the mirror, right? And then we will first draw, or from here the eyes are. So these eyes are actually seeing this, correct? So this should, okay. So this should, the range of the top of the wall should be in this eyes that we should see, correct? But actually it will not be like this. Basically what will happen is this is just a reflection. So the ray actually is coming, or the light is coming from here. So it is something like this. Okay, now this is just an illusion. This is the image. Okay, now similarly for the bottom end which we need to accommodate, we need to, you know first we need to have, okay, but actually it would be something like this. Okay, and actually the ray of light is coming from here, and then this is coming here. Okay, let me, okay, fine. Now we know a couple of things, like, we know if we draw a straight line, if we draw a straight line, if we draw a straight line, this is D and this is 2D, because this is 2D, D and D again, correct? Now let's assume this is X and this is Y, correct? Now if you've drawn this figure correctly, I think you're done. This is C. Okay, okay. Now again, let me reiterate how I have drawn this ray diagram. See, first of all, we are just seeing where this is the wall, height of the wall. What is its reflection here? What are the peak points of the wall? This and this. So we have to make sure that this, from or through this eye, this point and this point are visible. So what we are doing is we are just connecting this by a ray. From here, it is just a illusion. So basically this ray comes from here and then gets diverted this way. So actually the light is coming from here, right? But this guy will feel that it is coming from here. So we have just drawn complete. Same way, the bottommost corner of the wall is this. So we have to connect the ray through this line. But again, actually the light is coming from here and it turns here, right? So it's this way. Now it is very simple if you can draw the figure, correct? So first take this triangle and second take this triangle. Let's take this triangle. So now if I take this triangle, this is A dash, C dash, this is P, Q, C, X, correct? This is D and this is 2D. Now, by symmetry, we can say both triangles are symmetrical. And by symmetry, we can say A dash C dash by PQ is equal to C dash by CQ. Or we can say A dash C dash by X, okay, is equal to 3D by D. So this means A dash C dash is equal to 3x. Okay, now we will take this lower triangle, very simple, same way, exactly the same way. So if we draw the triangle, C, this is Q and R, C dash, B dash, this is Y, this is 2D, correct? This is D, right? So we can say, let me write it here, C dash B dash by QR is equal to CC dash by CQ. Or we can say C dash B dash by Y is equal to 3D by D. Or we can say C dash B dash is equal to 3Y. So now look at this. This means that C dash B dash is equal to 3 times of this. Okay, and A dash C dash is 3 type of this. So basically we add, that means if we club this and this, if we club A and B, we can say that A dash B dash is equal to A dash B dash is 3 times of PR. Okay, PR. So actually this is Q and this is R. This is R. So, and what is PR? PR is nothing but length of mirror. So we can say that to get full view, the length of mirror should be at least 1/3 of h height. Correct. So it is exactly the same way we have done it earlier as well. You know, we have drawn this diagram and then we have taken this triangle and the lower triangle. We have proved this as symmetrical triangles. This bigger one and the smaller one, bigger one and smaller one. And then we have done this, that this is, in the earlier case it was 2x twice, in this case it was 3 times. So the mirror needed to see this entire image, you know, of the wall. It should be, you know, this mirror should not be lesser than 1/3 of this. Okay, so that's proof. Yeah, thank you.